2, 3, action.
Yeah, hello. Good day to you. We are here to treat the simplest subject in the world, which is mathematics. And I hope you enjoy as we go on. Now, we're going to be treating the topic we call the number-based system. Number-based system is what we are used to, but I'm going to simplify it to the simplest form. That's going to help us understand it like never before. Let's ride on the journey. Number base. Now, this is very, very important for you to know before we go on. When you are writing a number down, you cannot exceed the base given. You cannot exceed the number base, the number given as the base. It's what I used to call a servant cannot be greater than his master. So if you are operating by any base, be it binary, trinary, up to denary, which is base 10, you cannot exceed. Any number going to write cannot exceed or even get to that number. For example, I will establish this before we go on because it's very, very important even in learning number base. Now, let's start from the simplest or the lowest base, which is what? Base 2, which is binary. Base 2. So if you're operating in base of 2, the number required for us to write should not get to 2. That means we have from 0, 1, but we must not get to 2. So we are going to write 0, 1. These are the two numbers permitted to be used when working with base 2. Now, if you are a computer person, you would have known that even your computer only works, okay, using the binary operation, which is 0, 1, 0, 1, 1, 0. You cannot exceed that, okay? But yet, now let's look at further example. If you are operating by base 5, what are we going to be writing? You're going to be writing what? We're making use of 0, 1, 2, 3, 4, but not 5. I think that is clear enough. So, but the everyday number we are used to when we were, from nursery school, primary school, now we are taught everyday number like 1, 2, 3, 4, and so on. These numbers do not have any base written at the bottom because they are natural bases. Natural bases are the numbers in base 10. Natural bases are the numbers in base 10. So every number you see without a base written, it's a natural base. So for example, if you have 17, just 17. 17 is just standing, it's not standing alone. It has a what? A base of 10. That is our natural number. So anytime you see a number without a base, you recall that it has a what? A base of 10. Please do not forget that whatever base we are operating by, we cannot write any number up to that base or more than that base. We're going to see more of it even as we go on. All right. I'm going to be writing some subtopics we are going to be considering under number base. Our first subtopic has to do with what? Conversion of bases. I'll just say a little about conversion of bases even as I try to explain this. Now, the second one has to do with what? Basic operations of bases. Now, your basic operations from mathematics, you know them. They are what? Your plus, your minus, your what? Division, and your what? Multiplication. So we are going to be what? Manipulating numbers with different bases based on these operations. Okay. Now, we are going to be moving on to the next one, which we call what? Conversion of bases with decimals. With decimals. Now, for JAMB students, you are going to be finding a lot of this, even in your examinations. And from there on, we would move on to another part, okay, that has to do with number-based system. But for now, let's take these three and let us see how they go. Conversion of bases. What are we trying to say, conversion of bases? It's just simply the same number, writing it in different forms. It's the same number, but we're writing it in what? In different forms. What do I mean? You may be given example. No, we want to consider conversion of bases.